So this is 1.6 geometry, 1.6, and today's lesson, it's a lot of words, okay? And I think you're going to want to keep notes today. We don't always keep notes, but today we're going to. So this lesson is all about what these words mean, and if you can understand that, you're going to have it. A little bit of math, okay? So I think the first one we better talk about is adjacent angles. Okay, so adjacent can mean a lot of things depending on what we're talking about, okay? But adjacent angles means that they share a common side. So adjacent angles would look something like this. Angle 1, angle 2. Do you see how they share this common side? Okay, that's what we're talking about when we say adjacent angles. Close to each other, not in the same figure, the same picture. They literally have to share a common side in order for them to be adjacent. That makes sense to everybody? So, how about angle 3 and angle 4 here? Are they adjacent? No. Okay, they don't share a common side. How about angle 3 and angle 5?
Yes.
They share. How about 5 and 4?
Yes.
Oh, you guys are so good. Okay, adjacent, we got it, right? Okay, that's what adjacent means. Okay, now that you know what adjacent angles are, I think I can explain to you what complementary means. Complementary angles. So complementary angles are angles that look at each other and they're like, ooh, you're looking quite acute today. Is that how it works?
No.
No! Angles are rude, actually. They never do that. Complementary angles, that's just two angles whose sum is 90 degrees. Okay? So that's all you got to know. Sorta. Sum is 90 degrees. Now, here's some things we have to concern ourselves with a little bit. If I have something like this, and then another angle over here, and this is 40 degrees, and this is 50 degrees, those two angles are complementary. Okay? Their sum is 90 degrees. Okay, so what about angle 6 and angle 7 here?
Yeah.
Okay, can you see that their sum is going to be 90 as well? So we all see the right angle marker here, right? Mm-hmm. Which tells us that's 90. Now, one of the problems becomes, I think we see them so often like this, we start to think of all complementary angles like this. Okay. That they're not complementary. But adjacent has nothing to do with it, okay? They can be adjacent like this, or they can be non-adjacent angles. As long as their sum is 90 degrees, they're complementary angles. You okay with this? Mm-hmm. Okay, everyone good? Mm-hmm. Okay, got that in your notes? All right, now, new word, supplementary. Have you heard of this one before? Who's heard of supplementary angles? Okay, a few of us. I'm going to abbreviate that, supplementary angles. What do we know about the sum of supplementary angles?
Up to 180.
Yeah, their sum is 180. Okay, so the two angles together give us a half circle, don't they? They give us 180 degrees. Now, Supplementary angles, again, they can be adjacent or non-adjacent. As long as their sum is 180, they're still going to be supplementary. Okay? So, again, I think we see this kind of situation a lot. Angle 1, angle 2 here. Okay? You see together, they're adjacent, and together do they make a straight angle? Okay, they make a straight angle. And so their sum is 180. And I think sometimes we start to think that all supplementary angles are like this. They're adjacent, you know, they look like this. I'm trying not to use another word that we're going to talk about here. But you just have to be aware that they do not have to be adjacent in order to be supplementary.
Teachers, would you excuse the tennis team to go now? Also, Joanna Snow, would you come to the office, please?
Well, serve and volley. It's your best bet. I don't know anything about tennis. Do you get anybody else?
It's called a match.
I'll tell you what though, one day I'll come to tennis, and if you beat me, everybody gets an A for that homework that day.
Okay. Go England.
Okay, so
Do I need to know lesson numbers?
I will put it on Aspire so you can see it,
Yeah, wait, there
and
is-
also on Canvas, and this video will be on Canvas so you can watch the rest of the video. Okay, hurry. Everyone's watching this video and they're like, will you guys shut up and get on with it already? Okay, let's go. All right, so non-adjacent, adjacent doesn't matter. They're still supplementary if their sum is 180. Now, this particular situation right here, okay, we want to talk about this. These two angles are called a linear pair. Okay? And you can see why. They make a line. Together, they make a line. They make a straight angle, don't they? Okay? All linear pairs are supplementary. These two things always go together. Okay? Ooh, I shouldn't have drawn it that way. I shouldn't have made the arrow over here. Every single linear pair, supplementary. Always. Every pair of supplementary angles, is it always a linear pair?
No.
See how it doesn't go both ways? Okay. Kind of like you guys. Every one of you, everybody in this class, a freshman. But is every freshman in our school in this class? Do you see how it doesn't go both ways? So, if you know something is if they make a linear pair, you also know they are supplementary. But just because I say, oh, these two angles are supplementary, it does not mean they have to be a linear pair, does it? Okay. Yes, ma'am.
So if they're supplementary and adjacent, does that make them a linear?
It does. If they are supplementary and adjacent, that's the only choice, isn't it?
Yeah.
Yeah. Exactly. Very good. Okay? All right, now, I'm going to make you think a little bit. Okay, so let's say we have two lines that come along, they intersect. They're in the same plane, they're either going to intersect or be parallel. These two happen to intersect. And I'm going to number the angles for us. Now, I just want you to look at this and say, what do you guys think about angle 4 and angle 2?
They're congruent.
Oh, good. They're congruent. I thought you guys were going to say they're the same. They're not the same angle. They are congruent, though, aren't they? Now, everything we've done so far in this class has been a postulate. We could look at it and say, well, that's the way it is, and everyone agrees with us, okay? This is the first time when it's actually complicated enough, and I mean barely complicated enough, that I can actually prove it. So this is a theorem, and it's called the vertical angle theorem. Vertical angle theorem. I'm just going to abbreviate a little bit here. So these angles that are across from each other like this, when we have two intersecting lines, we call them vertical angles. And you guys just told me that the vertical angles are congruent. How about 1 and 3? Are they vertical angles?
Yeah.
Do you think they're congruent as well? Yeah, I think so too. Okay. So I want to prove this. Now, I haven't introduced you to proofs yet. This is your first time. So here's what a proof is. A proof is a logical, step-by-step argument. Okay? You understand what I'm talking about? So I'm going to make a logical argument, and I'm going to go through step by step and show you that this has to be the case. Angle 4 and angle 2 have to be congruent. Are you ready? Okay, you got all your little gray cells ready to go? Yeah? Okay. So first thing I'm going to talk about is, what do you guys think about angle 4 and angle 1?
Equal 180.
Okay,
I mean,
are they a linear pair?
yeah.
That's the definition of a linear pair, right? Okay. Well, if they're a linear pair, what do we know about them? They're supplementary. And if something's supplementary, what does that mean?
It's supplementary.
Okay, so I'm just going to write this down. The measure of angle 4 plus the measure of angle 1 is equal to 180 degrees. Does everyone follow?
Mm-hmm.
Okay. Now, let's go over here. Angle 1 and angle 2. Are they a linear pair?
Yes.
Okay, are they then supplementary?
Yeah. Mm-hmm.
And what do we know about every set of angles that's supplementary?
Equals 180.
Okay, so I'm going to say that the measure of angle 1 plus the measure of angle 2 equals 180. Okay, now we don't have to look at the picture anymore. We're going to do some algebra stuff now, okay? So, last year you learned if two things are equal to the same thing, they must be equal to each other. You agree with that? If A is equal to B and B is equal to C, then A is equal to C. Okay, so if they're equal to each other, then I'm going to say the measure of angle 4 plus the measure of angle 1, this top one, equals the measure of angle 1 plus the measure of angle 2. I could also say I'm going to substitute. I'm going to take this and substitute it for 180 since they're equal to the same thing. Since they're equal, can't I substitute one for the other?
Yes.
Okay. Do you see where I'm going, everybody? Okay. So now I'm trying to show that angle 4 and angle 1. No, I guess I'm going to have to do 4 and 2. Excuse me. That those two vertical angles are congruent. So I just want you to notice right here and right here. And I tried to make them come out in the middle. They're just a number, aren't they? Isn't the measure of angle 1 just some number? Right? Can't I subtract that number from both sides of this equal sign? Okay, so if I subtract whatever the measure of angle 1 is from both sides of the equal sign, is that legal? Is it still equal? Yeah, that's just the subtraction property of equality. So the measure of angle 4 is equal to the measure of angle 2. And if that's true, then I'm going to say angle 4 is congruent to angle 2. I mean, isn't that the definition of congruent? Yeah, that's what congruent means, that they have the same measure, right? This argument I just made for you, now I haven't written the whole argument out. I didn't do a whole formal thing and everything. But the argument I just presented to you is called the vertical angle theorem. And so now, okay, well, what can we say about angle 1 and angle 3? Okay, angle 1 is congruent to angle 3. And what is our reasoning now? Vertical angle theorem. We never again have to go back through and prove that vertical angles are congruent. We just did it. So from now on, when we say, hey, they're vertical angles, so they're congruent, what's our justification? Vertical angle theorem. Okay, that's how we justify it. Okay? Okay, so I want you all to turn to page 51. Can you do that for me, please? Well, we better go to bottom of page 50 first. There's a figure on example 5 at the bottom of page 50. Looks something like this. X degrees, 5x degrees. This figure right here, the two angles are labeled. Can we come up with an equation where we can solve for x? What do we know about 5x degree angle and the x degree angle? Yeah, they make a linear pair, so they're supplementary, so their sum is?
180.
Okay. So 5x plus, is it okay if I say 1x? So 6x equals 180. Is that 30? Does that seem reasonable? That one would be 30, this would be 5 times 30. Does that work? Yeah? Do you guys take your answer and plug it back in and make sure it makes sense? I see some of you are yes, and some of you are like, no, that would take longer. Check your answer, okay? Make sure it just is sensible. One nice thing about mathematics is when we screw up, it's obvious. If you think about your answer, you'll see there is no possible way that can be right. Okay? It's not like we're sort of close. You know, if you set up the equation wrong, you're going to be so far off you'll know. Okay? Now look over on page 51 now. See the concept summary? Right in the center of the page there's a figure. Y'all looking at it? Okay. What can you tell me about angle ABC? Okay, is it a straight angle?
Yeah.
Are you sure it's not like 179 or 181 or something? You are. Okay. If it's not supposed to be exactly 180, if it's not supposed to be a line, okay, like this, where we actually have a straight angle, it'll have enough of a bend in it that you'll be able to see it's not. Okay, they're not going to try to trick you. That's not the point of this. Okay, so you can definitely assume that angle ABC is a straight angle. Now, look at angle ABD. Is that a right angle?
Yes.
We don't know. We do not know. Okay, it may be, it may be not. Okay, how about angles DBE and EBC, the two smaller on the right? Are those two angles congruent? Oh, we don't know. Okay, but do we know what bisects them? We don't. Just because it looks like it's that way, you can't assume that. Okay. What about point B? Is it the midpoint of AC, segment AC? You don't know. Okay, now look at the bottom of the page. Look at point B. Is it the midpoint of segment AC?
Yes.
Okay, we know. See the marks? Is angle ABD a right angle?
Yes.
Angle DBE and EBC, are they congruent?
Yes.
Yes, see how they're marked with the same angle marker? They each have a single red mark in them, don't they? What about ray BE? Is it a angle bisector?
Yes.
Yes. Are each of those smaller angles 45 degrees?
Yes.
They have to be because they add up to 90, don't they? Okay, so I guess we just want to make sure we understand what we can conclude and what we cannot conclude. Don't go overboard. Make sure you read the instructions. Sometimes they'll have a figure that may look like this, like the one we had before. And that's all it says on the book. But then in instructions, it'll say ray BE is an angle bisector. So that means when you draw that on your paper, you want to go ahead and mark those congruent, right? Or it might say point B is a midpoint of AC, so I'm going to mark those congruent. And that DBA, that angle, is a right angle. So it might not be marked in the figure, but it might tell you in the instructions things. Okay, so you want to make sure you know what's going on there. Okay, turn to page 52. Let's look at number 2. Do a little Sesame Street here. Which of these things don't go together? Let's say first picture, second picture, third picture, fourth picture. Third? First?
It says it's a writing.
So in the first picture we have a right angle. Aren't 1 and 2 complementary?
It's the third one. It's the third one.
Okay, so in the third one, angles 3 and 4, they form a linear pair. They're supplementary. But in the first, second, and fourth, we have complementary, right? Complementary. Okay. Here you go. This is chapter 1.6. It is due at the first of class tomorrow.
Do we do it with our notes or?
I would do it on a different paper so that you can keep your notes for the test, because I don't hand these back. Remember, you can use all of your notes on the test, right? Notes, books, tattoos of the Pythagorean theorem on your arm. It's all good, right? Okay.